name is Carme Homs. I'm 18 years old and I'm from Barcelona in Spain. And I've always been very interested in astrophysics, and this is why I think that this camp is a unique opportunity for me because it offers me the chance to learn about the solar system, to know how astronomers actually work, and it is also a great opportunity to meet people from all around the world. So I would really like to take part in this camp. My favorite astronomical objects are Cepheid variables. Cepheid variables are very bright stars and they are classified as pulsating stars. This means that they experiment changes in luminosity. So one day they appear to be dimmer, then brighter, dimmer. And if we plot what we see in the graph, then we put its apparent magnitude in the y-axis and time in the x-axis, then we obtain something like this. So we can see that they have very regular periods, which are typically in the range of 1 to 100 days. And also, we can see that there's a rapid rise in brightness followed by a more gradual decrease. And this is a very distinctive light curve which helps us to distinguish Cepheid variables from other light phenomena such as eclipses. So why do Cepheid variables pulsate? Main sequence stars like our Sun are in hydrostatic equilibrium. This means that the gravitational inverse force is balanced by the radiation pressure. So the star doesn't show any changes in size. But this is not the case of Cepheid variables. When Cepheids are in its Zimmer phase, they have very high temperatures on the surface, and this allows the formation of double ionized helium, which absorbs radiation. So double ionized helium gets heated up, and therefore the radiation pressure increases, so the star is meant to expand. Well, once it is expanded, the temperature on the surface is now lower. So we no longer have double ionized helium and we have single ionized helium instead, which doesn't absorb radiation that much. So the star appears to be brighter, but also the radiation pressure is now smaller. So the gravitational inverse force is bigger and the outer layers of the star are meant to contract again. But the most interesting point about Cepheid variables is the fact that they are standard candles. This means that they are stars of known absolute magnitude. So, thanks to this woman here called Henrietta Leavitt, we now know the relationship between Cepheid variables' absolute magnitude and its period. We have to write the period in logarithmic scale though. So, if we have a galaxy and we find that there's a Cepheid variable in this galaxy and we manage to measure its period. We also know how bright this Cepheid actually is, and of course we know how bright it appears to be. So we have everything we need in this formula to down here to find d, which is the distance between the Earth and the galaxy. And this means that Cepheid variables are a very useful method when it comes to measuring distance, and they can be used as an alternative to parallax when the distances are so big that parallax is not a working method, and this is why they are my favorite astronomical object.